Hi, today I'd like to talk about Pythagorean triangles. And just to clarify, a Pythagorean triangle is a right triangle where each side is a whole number. For example, the one of the more well-known is the 3, 4, 5 right triangle, where one side is 3, one side is 4, and one side is 5. Okay, where they satisfy the Pythagorean theorem, but they're also whole numbers. So now it brings a question. How many Pythagorean triangles can we find that are not a scale-up version of other Pythagorean triangles? So, for example, a 6, 8, 10 Pythagorean triangle would not qualify because it's a scale-up version of that one. So to answer this question, first thing we're going to do, we're going to get a generic right triangle, okay, where we have a side that's A, a side that's B, and one side that's C, and a right angle here indicating that's a right triangle. And we know that C squared is equal to A squared plus B squared. Okay, so now what we're going to do is slightly different. We're going to let A equal X. We're going to let B is equal to the square root of 2x plus 1, and C is equal to x plus 1. And so now if I apply the Pythagorean theorem to this side, we're going to get C squared, that's going to be x plus 1 parentheses squared is equal to A squared, which happens to be x squared, plus B squared, which happens to be whatever is in this squared, which is just going to be 2x plus 1. As we know, this is accurate. And this, again, as I said, is C squared. That's A squared, and that is B squared. Now, as we know, since x is a whole number, it should be pretty clear that 2x plus 1 should be an odd number, okay? So all we have to do is find a square number that is also an odd number. Well, to do that, it's quite easy. All we have to do is take an odd number and square it. Okay, so if you take an odd number, okay, that's going to be B. And you square it, okay, and set that as equal to 2x plus 1. So now to find A, all you have to do is minus 1 divided by 2, and you have A. Add 1 to that result, and you got C, okay? So here's an example. So let's say we have 11, okay? So we're going to say B is equal to 11. So I square that, I get 121 is equal to, in this case, 2x plus 1. So in this case now, I minus 1 divided by 2. We know now that x, which happens to be equal to A, is now equal to 60. And in which case C, okay, is just basically 1 plus that, so 61. So we know that 11, 16, 61 is a right triangle. So now, because there are an infinite number of odd numbers, okay, we can essentially make an infinite number of Pythagorean triangles, okay? Now all we have to do is prove that they are not scaled-up version of other right triangles. Well, to be a scaled-up version of another right triangle, all three sides have to have a common factor. In this case, here, they have a common factor of 2, okay? Now, consider in mind that if two numbers differ by 1, in this case A and C, okay, they cannot have a common factor that's greater than 1, okay? So that means the triangles which I just found cannot be a scale-up version of another Pythagorean triangle. Other examples of Pythagorean triangles might be 9, 40, or 41. Okay, using the same technique. Okay, we can also find one, okay, if we want to go extreme, okay, of 1001, okay, 501,000, okay, and 501,001, okay, and those are just examples. But basically what I'm saying is that because just about any odd number that's greater than or equal to 3 in this case can be a side of a Pythagorean triangle, it means then that the number of Pythagorean triangles that are not scaled-up versions of other Pythagorean triangles is infinite. Anyway, I hope you find this informative, and I'd like to thank you very much for watching.